in this section, we're going to review what we know about linear functions. So let's start by talking about everything that we should know about slope. Slope represents both the steepness of the line and the rate of change of the function. So if I have a function like y equals 3x plus 2, the slope represents the rate of change of that function. That number also describes how steep or how flat the line is, okay? So the linear function, y equals 3x plus 2, represents the rule for finding all possible ordered pairs xy, while the graph of the linear function represents the picture of all possible ordered pairs xy, okay? Slope can be defined in several ways, but they all represent the same thing, the rate of change of y compared to the rate of change of x. And so that's why we see things like rise over run or delta y over delta x. The letter m is typically used to represent slope when we're working symbolically. So here's several different ways. We can see rise over run. That's going to help us a lot if we're looking at a graph. We can count the change in y over the change in x. Or if we have the ordered pairs, we know that the formula is y2 minus y1 over x2 minus x1. The order of your y's and your x's, it doesn't matter in terms of which ordered pair you use, but it does matter that these two come from the same ordered pair and that these two come from the same ordered pair. So you could do y1 minus y2 as long as you also did x1 minus x2. You just have to keep those ordered pairs lined up top to bottom. You learned in previous classes as well the slope-intercept equation of a line, which is y equals mx plus b. If we remember from that one, m is always going to represent the slope of the function, and b is always going to represent the y-intercept. The y-intercept is where the graph crosses on the y-axis. That's going to be the value of b. The second equation of a line, and this is the one that in our upper level math classes we use the most. It's the most useful. I prefer it to slope-intercept form. And that's the point-slope equation of a line. So when you want to use point-slope equation, that's because you've been given a point, which is the point x1, y1, and the slope, which is, as we know, m. So if you know the slope and one point, you can very easily figure out the point-slope equation, okay? That one does not give you the y-intercept necessarily. It gives you any point on the graph. So let's look at these examples of figuring out some slope. So I want to start by finding the slope from a graph. On a graph, the easiest thing to look for is rise over run. And the first thing I want to do is pick some friendly points. So here's an example of a friendly point. It crosses right on the grid lines, not something like this point right here that I would have to estimate. I don't know exactly where that crosses, so I don't want to use that. So let's find another one. If I work my way down, maybe here is another good one, okay? I always count to the right, and then I go up or down based on my run. So in this case, to get from the left point to the right point, I need to go down, so that's a distance of -2 because we're going down. And then to the right, I need to go 3. So in this case, the slope is rise, which is your vertical distance, the change in y. So in this case, that's -2, over run, which is our horizontal distance, which is 3. Pause the video, take a moment to try B on your own. Okay, pick two friendly points. I've already got 0, 0 marked. This looks like another good one. So moving from right to left, I first need to go up 2, so that's positive, and then to the right 1, so that's positive. So our slope, rise over run, is 2 over 1, but really that's just the number 2. All right, moving on. So from an equation, we can determine the slope. But remember, the only two forms of the equation where we have the slope are going to be y equals mx plus b, or the point-slope equation, which is y minus y1 equals m times x minus x1. It's got to be in one of those two forms to find the slope. If I look at C, y equals 3/5 x plus 1, that one's already in slope-intercept form. And so I can see that m is 3/5. A common mistake is to say that it's 3/5 x. X has its own job. Slope is just the number, and so it's only going to be the coefficient of x. If I look at D, 4x plus 4y equals 16, that doesn't match either of those forms. So our best bet here is going to be to work to get y by itself so that it is then in slope-intercept form. So I'm going to start by subtracting 4x. 16 and negative 4x are not like terms, so we can't combine them, but I do know that I want it to be mx plus b, so I'm going to put the negative 14x first, and the 16 was positive, so we're going to keep it a plus. And then we'll divide by 4, and we have to divide every single thing on both sides. So now I have y equals negative 1x plus 4. And now we can see here the slope is negative 1 because that's the coefficient of x. E looks messier, but it's not because this is point slope form right here. So we just have to identify the right piece, and here's where our m is, so we can see that m is negative 2. Okay, so that's using the equations to determine the slope. Question 3 wants us to find the slope between 2 points, so we don't have a picture. This is where we're going to use the slope formula, which is on the previous page. M is equal to y2 minus y1 over x2 minus x1. Okay, so it helps to decide which one's going to be your 1s and your 2s. Again, the order of the pairs doesn't matter. So we could say I'm going to call this one x1 and this one y1. And that would make the second point x2 and y2. I think it helps to label it to keep track. So now the rule for m is going to be y2, which is 7, minus y1, which is 3, over x2, which is 4, minus x1, which is negative 1. So 7 minus 3 is 4 over 4 minus minus becomes a plus, so we really get 5. There's our slope. Pause your video for a moment and see if you can determine the slope for G. I'll be back in 2 seconds. All right, we're going to set this up the exact same way. Now, again, just to prove a point, it doesn't matter if this is my 2's. As long as both 2's are in the same point and both 1's are in the same point, it's fine. So I could find my slope this way and do y2, which is 7, minus y1, which is negative 1, over 2 minus 2. So what you should get here is 8 over 0. Now this is really important. 8 over 0 is not a number that exists. We cannot divide by 0. And so 8 over 0 is not an acceptable answer. Instead, we know that division by 0 is undefined, and so that is what we will call the slope. This slope is undefined. A quick little reminder, a good way to remember this is n over O is no. That one is undefined. O over K is okay. That one's equal to 0. 0 on top is okay. 0 on the bottom is no. That one gives you undefined. All right. So we do have some special cases, and that last one was an example of a special case. Horizontal lines have a slope of 0, and vertical lines have an undefined slope. And again, this is what I just mentioned, that results from dividing by 0. So that's the previous example right there. So that's how we can determine the slope. Once we have the slope, we can write the equations of lines. And so depending on what we've been given, we need at a minimum a point and the slope. So if you need a point, there's several things they could give you. If they give you the y-intercept, which is always the initial value, then that's B. So you have the y-intercept, you can start from there. If you're given 1 point, then that's the one that you want to use. And if you're given 2 points, that's even better, but we only need 1. So you're going to just choose the one that you like the best. Then to figure out the slope, they're either going to give it to you or they're going to tell you what the rate of change is. that tells you what the m should be. And then if you're given 2 points, we have to use the slope formula to figure out what the slope is. So we do need both points to figure out the slope, but to write the equation, you can pick whichever one you like. All right, so let's do these last examples here. The slope-intercept equation of the line with a slope of -2/5 and a y-intercept at 6. Well, they gave us all the good stuff here. -2/5 is m. 6 is the y-intercept, and so that is our value of b, and the slope-intercept equation is y equals mx plus b. So to write this, we're going to have y equals m, which we know is 2/5 x, plus b, which is +6, so it'll stay at plus. There's our equation. Number 5, we can look at the graph. Now, again, what I need is the slope and the y-intercept if I can get it. I can see on the graph that my y-intercept is -3. That's where it crosses the y-axis. And then we can determine the slope by looking at rise over 1. So it looks like I go down 1 and over 2. So our slope would be -1/2. So there's all of our pieces. Y equals -1/2 x minus, because it's -3. There's our equation. So the last 3 examples is where it gets just a little bit trickier. So number 6 says, write the point slope equation. So the first thing we need to know is what form is that? That's y minus y1 equals m times x minus x1. The 2 pieces we're looking for are the ordered pair x1 and y1, and we're looking for m. So write the point slope equation of the line with a slope of -2, ding ding, there is m, through the point -1, 4. Well, that's great. That's our x1 and our y1. So we're just going to plug in. What's really important is this y and this x stay exactly the same. That's the x and y that will remain in your equation. So we're going to leave those alone. But I'm going to get y minus y1, which we see is 4, equals m, which they told us is -2, times x minus -1. Now, we don't ever want to leave double signs like we have there, minus, -1. So we're going to rewrite this to be y minus 4 equals -2 times x plus 1. And anytime you subtract a negative, it's going to switch the sign. So you can go ahead and go straight to that. But this would be your final answer here. Okay? Since it asked us for point slope, we're going to leave it like that. It is possible that they asked us for slope-intercept, in which case we could distribute the 2 and add 4 to both sides to get y by itself, and then we would be done. So on number 7, it says, write the slope-intercept equation of the line through the points 7, -3, and 9, -4. Again, we need 2 things. We need a slope, which we don't have, and we need a point, which we have 2, and we only need 1. So we've got what we need there. So the first thing we need to do is determine the slope between these 2 points. So pause your video and see if you can find that slope. All right, we should get -1/2 for the slope. Now, because I have a point and a slope instead of a slope and a b, I'm going to automatically start with the point slope equation because those are the things that I have. And I'm going to use this point as my x1, y1. You can use the other. It should give you the same answer at the end. So when I set this up, I'm going to say y. Now again, here's where we can think ahead. Minus -3 is going to become y plus 3 equals -1/2 times x minus x1, which is 7. That's the point slope equation, and they asked us for the slope-intercept equation. So now we have to do a little bit more work. I'm going to start by distributing this -1/2. So I have y plus 3 equals -1/2 x plus 7/2. And then I need y by itself, so I'm going to subtract 3. Now on the left, we need a common denominator to do this. So 7 over 2 minus 3 over 1. Common denominator would be 6 over 2. So when I subtract, I'm just going to get 1/2. So our answer is y equals negative 1/2 x plus 1/2. That is the final answer there. So even though we wanted slope-intercept in the end, we still started with point-slope equation because a point and a slope is what we had. The last two examples here are word problems. And so this is where this language from above is really important. The y-intercept is the initial value whenever we're talking about word problems. And the slope is always the rate of change when we're talking about word problems. So we need to identify those two things. Number 8 says, a tree with a diameter of 2 inches is planted. The diameter of that tree grows at a rate of 1/2 inches per year. So we're looking for the rate and the initial value. Well, here we go. 1.5 inches per year, that's our rate. So that tells us our slope. And it's growing, so the rate is positive. If it were shrinking or something, we'd make it negative. And then it says it started with a diameter of 2 inches per year. So that tells us our y-intercept is 2. It says let y equal the diameter of the tree and let x equal the number of years since planting. So the formula to find the diameter, y, is going to be equal to the rate, 1/2 inches per year, times x, which is the number of years, plus the initial value, 2. Number 9 is very similar. Look for your initial value and your rate. I'm going to pause here for just a second, see if you can write down what that would be on your own. All right. That word initially is really important. A rental car costs $40 initially, plus a fee of 0.10 cents per mile driven. That word per is usually a clue that you're looking at a rate. So we should have y equals 0.10x plus 40. And there you go. It's a quick refresher over all we know about lines and slope.